Okay, so here we have question 2. It says here the question concerns the elements of group 1 of the periodic table and their compounds. I think that's key, their compounds. The table below shows the results of tests carried out on 3 white group 1 compounds A, B and C. The flame test, at this point you should be remembering the colours of the flame test and which metals they indicate, are carried out on solids, and the silver nitrate tests on solutions of the compounds. And the silver nitrate test, a little bell should be ringing telling you that this identifies halides depending on the colour of the precipitate, and you do need to learn the colours of the precipitate for the silver nitrate tests. Okay, so we have here the test. We've got the flame test going across this row and the silver nitrate going across this row. So it tells us that compound A produces a lilac flame, and that will tell us that compound A contains potassium, but also the silver nitrate test produces a cream precipitate, and a cream precipitate tells us that compound A contains the bromide ion. So compound A is potassium bromide. Okay, looking at compound B, okay, it produces a red flame, and red indicates lithium, and it produces a yellow precipitate. And a yellow precipitate of using silver nitrate indicates that we've got silver iodide, or iodide was present in the original compound. So B would be lithium iodide. And then finally, C, the yellow flame, tells us that sodium is present, and the white precipitate in the silver nitrate test tells us that the chloride ion is present. So C would be sodium chloride or common salt. Okay. Now, for part 2, I need to read this carefully. Give the symbols of the ions of the group 1 elements present in A, B and C. So the group 1 elements are potassium, lithium and sodium. Okay, so we first of all need to find the symbols. So at the back of your exam paper you'll find a periodic table in case you're not sure. So group 1 we have here lithium, sodium and potassium. And then it does say ions, so we need to be careful. An ion has a charge. So if we're not sure, we can check in the back of the table, the paper again. And okay, sorry about that. I had a technical issue there. So the sodium ions, sorry, the group 1 ions rather, are in group 1, so they're single positive charge, single positive charge, and single positive charge, and those go there. Okay. Explain how the ions are formed from their atoms. Well, if an atom becomes positive, it's because it's lost 1 electron. Okay, so the atoms lose 1 electron. And to be to a full answer, we could say from their outer shell. Of course, they do that in order to reveal the full outer shell beneath. Part B. The table below shows the results of tests carried out on two white group 2 compounds, L and M. The flame tests were carried out on solids and the silver nitrate test on solutions of the compounds. So very similar to the previous question, just need to be aware of our flame colours and the significance of our silver nitrate results. So apple green, okay, is associated with barium, and we need to learn that. And as we saw previously, the white precipitate is associated with the chloride ion. And then the brick red colour, as opposed to a simple red colour, is associated with calcium. And the yellow precipitate, as again we saw earlier, is iodide. Okay, in part C, silver nitrate solution is used to detect the presence of halides ions in solution. The equation below represents the reaction between silver nitrate solution, that's here, and lithium bromide solution, which is here. And we can see that we get an exchange of ions. So the silver ion gives up its nitrate and gains the bromide, and the lithium ion gives up its bromide and gains the nitrate. Complete the ionic equation for the reaction, include state symbols. Okay, so in this particular equation, we're only interested in the silver bromide. So we need to know which ions react together to form silver bromide. So we can probably be confident to put Ag there, and we can put Br there. Okay, however, we need to add the ionic element, which is a charge, and we also need to include the state symbols. Okay, so as far as the ions are concerned, if we look at our table of ions in the back, just to double check, we will find that the silver ion, okay, which is here, we can't see that, the silver ion is Ag+, and while we're here, we'll notice that the bromide ion is Br-. Okay, so silver is a simple charge, a positive charge, bromide is a negative charge, but it also asks for the state symbols. Okay, the state symbols. Now, if we look at the question again, we'll notice that we've got the word silver nitrate solution and a lithium bromide solution. If you see the word solution, then that tells you it's aqueous, that means dissolved in water, and the symbol for that is AQ. Okay, so that's the state symbols for those two. Now, complete and balance the symbol equation for the reaction between calcium chloride solution and silver nitrate solution. Okay, so in these sorts of questions, if you see a box, that tells you there's going to be a number in there that's not a 1. Okay, they don't put boxes in front of symbols, in front of formula where it's going to be a 1. We've also got a complete gap here, which tells us that there's going to be to work out a formula. So if we have a look at the previous question, we saw there was this exchange in ions. So the silver ion lost the nitrate and picked up the bromide and so on. So a similar thing happens here. So we're going to look for calcium nitrate. Okay, so a good place to start would be to write down calcium nitrate. Okay, so we can see the nitrate ion is NO3. Okay, but what we do need to check is the relative charges on these two ions so that we can work out the overall formula. So again, if we refer back to our ions in the front of the back of the paper rather, you'll notice that calcium is a 2+ ion and the nitrate is an NO3- ion. And what that means is we need 2 nitrate ions to electronically balance 1 calcium ion. Okay, because we need a 2- and a 2+ that cancels each other out. So in our formula, we have to show that there needs to be 2 nitrate ions. And in a formula where you're writing the overall compound formula, we use the convention of the brackets and the number. Okay, so this gives us the formula for calcium nitrate. Having done that, of course, we now need to balance this equation. Okay, so we can assume that these are balanced because there's no numbers required. So what we need to do is have a look at the silver nitrate. And a quick fix for this might be to consider the nitrate. So on this side of the equation, on the left-hand side, where we've got the, sorry, I'll put that in the shot, where we've got the reactants over on here, we've got one nitrate ion here. Over here, we've got two. We've just worked out we need two. So it would seem that a sensible number to put in there would be a 2. So if you do that, you've now got 2 nitrate ions. If you put a 2 there, meaning we also have 2 silver ions or 2 silvers, over here we'll need a 2 there. And just to double check, we've got 2 chlorines and we've already got 2 chlorines over here. Okay, so that was the balanced equation. And then moving on, lithium lies above potassium in the periodic table. Now that's a clue. That should be making you think, lithium is above potassium, so it's less reactive. Okay, so give 2 similarities and 2 differences between the reaction of potassium and lithium with water. Okay, so there are various things we can put in there. So we'll start with similarities. Okay, so they both produce hydrogen gas. Okay, so that would be a similarity between the two. And then they both produce hydroxide. They both turn the water into an alkali. Okay, and that's due to the presence of sodium hydroxide. No, sorry, not sodium. Potassium hydroxide and lithium hydroxide. Okay, but perhaps more simply, they both move around the surface. Okay, and they both float. So we've got more than 2 similarities there. Okay, so this is unusual for a metal that they both float. Let's put the both form hydroxides. So any 2 of those would do. And then for differences, okay, we've got that potassium being more reactive because it's lower down the group, melts into a ball and then ignites. Okay, so it actually burns, and it burns with a lilac flame. Okay, and that does tell us that it's more reactive. Okay, so generally potassium is more reactive. Okay, so we've got in here we've got the melts, and it forms a ball and it ignites, and overall it's more reactive. Okay, so there's a range of different options for you there. Okay, part 2, complete and balance the simple equation for the reaction between potassium and water. Okay, so for this one, a little bit of knowledge would be handy here. To know that when a group 1 metal reacts with water, we get a metal hydroxide and hydrogen. Okay, so the metal on this occasion would be K, and the hydroxide ion, and we can check this on the table, but if I tell you that the potassium ion is plus and the hydroxide ion is minus, then this automatically balances out electronically, so that the positive and the negative cancel each other out. But we do need to work out these 3 boxes here. Now, as I said earlier, if they put a box in front of a compound, it's not going to be a 1. It's going to be anything but a 1. Okay, so we could go through the process of doing the box model. So let's do that. So we've got a K, then we've got H2O, which is HHO, then we've got KOH, and then we've got H2, which is that. Okay, so we've got 1K here, and we've got 1K there, so it's looking good so far. 2 H's here, but we've got 3 H's altogether on this side of the equation. Okay, so that's no good. The only way we can solve that is to add in an extra KOH, because that will make the number of H's on this side even. So we've got 4 H's on this side, and to get 4 H's on this side, we need that compound there, that symbol there rather. And in doing this here, we've added an extra K, so we need another K over here. And hopefully that's all balanced now. So to add the numbers to the boxes, we need a 2 in that one, we need a 2 in that one, and we need a 2 in that one. Okay, so I think that is the end of number 2. It is indeed the end of number 2.